Finally, we're in probably the most important section of the book. This is the most crucial topic. You'll talk to anybody in 1800 Calc 1, and they'll tell you that there's one topic they consistently use, and that's this one. And it's a very important method, but it's getting grouped into this one thing that we're going to see a lot in this course. But it applies to many different things and many different aspects. So we're going to spend quite a bit of time talking about how to solve these kind of items, okay? So, section 8.9 talks about nonlinear inequalities. So first of all, let's talk about what the hell a nonlinear inequality is before we start talking about anything else. Okay, so what is a linear inequality? Let's start with that. Before we talk about nonlinears, well, what is a linear guy? Well, a linear guy, well, if you guys remember what linear guys are, excuse me, that's a y equals mx plus b. So a linear guy would look like, I don't know, for example, let's say negative 3x plus 4. Okay, so that's linear, right? So mx plus b. Okay, so if you're not one of those, you're in the other category. So I don't know what nonlinear is. Nonlinear could be a whole array of things. Okay, from good to bad, ugly to sad. Okay, so for example, this guy is nonlinear. Nonlinear example. Okay, so a nonlinear guy could be a guy that looks like this. X squared plus 3x plus 2, right? It's quadratic. It's not straight, right? Something very basic. Or it could be that divided by this, which is x plus 4, right? There's no fancy rules here, right? Does it look like y equals mx plus b, mx plus b, 2x plus 3, something? If it doesn't, then it's not linear, okay? I don't care if, here's a trick one that gets a lot of people. 1 over x plus 4, linear or not linear. mx plus b, not x in the bottom. X is out by himself. He's out there by himself, right? There's no reason why the x should be down there. So that's a nonlinear as well, okay? The only guys that run this show is if they look like this. But there's a reason why. There's a reason why these two guys are kind of in a separate category. And I think it's because there's a misconception on how we learn to solve these. Okay, so check it out, okay? And cut me some slack here, okay? And you'll see why, because there's a big deal here. And then we'll zoom back in and we'll talk about the other ones, okay? So for example, let's talk about a linear inequality. Okay, let's focus there for a second, okay? Spend a couple seconds here. So let's say, for example, we had negative 3x plus 4. Let's say I wanted to know when this thing was greater than 0. And you would say, okay, well, if negative 3x plus 4 is greater than 0, that's easy, right? We could just subtract stuff off and we would do this. And we would do some stuff like this. And we'd say, oh, well, don't forget, if you're multiplying or dividing by negative numbers, you must flip the sign. So this must be a positive 4 over 3, okay? Now, this is what they taught you way back when. But what does this even mean? Like, what does this mean if we're trying to solve this inequality? Right? Like, what is this actually asking us? And then what is this the solution of? Okay, so it's basically asking the overall question. So this is why these two things, linear and nonlinear, are different. And this is in the key. Okay? If you're linear, when you graph it, what are you guaranteed to get? It's in the name. A straight line. You're right. Okay, so check this out. If it looks like negative 3x plus 4, okay, then I know it's going to have a y-intercept of 4 and do something like this, right? It'll look something like that. Okay, so here's the point. What you were actually solving, and this is going to be really complex, this is a y value, right? So think of this as a function, right? It's a y value, right? Y equals x plus b. That's the y part, right? So 3x plus 4, well, that's the y values, right? So you're telling me then the numbers. I want to know when this thing is bigger than 0. I want to know when it's bigger than 0, okay? Well, when you're y, when you're bigger than 0, where are you? You're right here. Right? That's where the y's are bigger than 0. They're not negative. They're not 0. They're bigger than 0. That's there. Well, which x values does that mean? Well, here's the point. This x value, we all know what that is. But what this is answering is that all the x values that satisfy, so all these x values from here on back, right, which is what the answer was, it satisfies it because this thing is a straight line. So what you really don't know is two facts, okay? One is when you were solving inequalities back in the day, they couldn't tell you what I'm getting ready to tell you. They had to say, okay, remember when you multiply or divide, flip the sign. Well, this is weird, okay? So let's think about it, okay? What are you solving? You're solving something. Well, this here is you solving something that has a straight line effect, okay? It goes straight up to straight down, which is what this is, okay? So if it goes straight up to straight down, now check this out. I want to know when that's positive. When that line's positive, that means when it's above the x-axis. When it's above the x-axis. Well, when it's above the x-axis, that starts right here, and that's all these x values back this way. So it's 4 over 3, and then all the way back. Bingo. Okay? So that's really what you were answering. Seems like a heck of a lot less work to get that kind of understanding. Well, here's the good news. Okay? The good news is that the work now is going to be justified for the understanding. Because if you're a nonlinear inequality, this thing right here, we could solve that if we knew how to tackle it. So, and what I mean by that is this thing right here, this guy, he's going to look something ugly. I mean, just something ugh. And let's say we're trying to solve when he was greater than 0, and he looks something maybe like, I don't know. And the only reason I can do this is because I know a little bit more math than you guys, I think. Yeah, I think something like that. So, bottom line is that's pretty ugly. So, but if I'm trying to figure out when that thing is greater than 0, that's only from here to here, and all these guys too. So it's a really tricky. You're not going to be graphing them like this. I just sketched the graph for you. But here, we have to come up with a better methodology behind getting in there. All right? So here we go. That's what we're going to delve into today. And it's the same methodology. It's just you got to know what to do. So here we go. Rock and roll. All right. So I'm going to clear some paper out here. So this is what we need to do. So let's say, for example, I wanted to solve this guy. Let's say they said, okay, here's my function. X squared plus 3x plus 2 divided by x plus 4, and I want to know when this thing is going to be less than or equal to 0. So the key behind solving nonlinear inequalities is one major thing, okay? Never clear the fraction. And why is that? Because if you multiply that and you clear this out, you don't know whether or not it's negative or positive, right? Because you don't know what x is. And when you do that, you don't know whether or not to flip the sign. And that's when things go all array. So you can never, ever do that. Okay, so be careful. So that's the first thing, okay? Second thing, okay, so never, ever clear the fraction. You got to deal with what it is, okay? Second thing, tip from me. Always factor it out and make sure life's a little bit easier. So I like to work in factors. And because it's called a sign chart for a reason, and I'll make sure to reiterate this within the next couple seconds, okay? Now, once you are here, this is what you need to do. Throw away the inequality. Okay, throw it away. And what I mean by throwing inequality, I'm not even looking at this. I'm going to cross this out. It is not an interest of mine. Okay, what I do want to look at, though, is I want to look at this. Okay, because that inequality is saying I want that thing on the left to be negative, less than or equal to 0, right? Be negative or 0. So if it's going to be those things, then I need to figure out what needs to happen on the left-hand side. So let's talk about that, okay? So once you get a factor and it's all cute, if it's factorable, okay, bottom line is you're going to look for two things. You're going to look for, number one, when is this thing going to be undefined? And you'll hear a lot of people call them bad numbers. Okay, so when is this thing So what makes this thing undefined? And this is not a new concept, guys. You learned this back when we talked about domain. It's a domain restriction. So that's the thing that makes the denominator equal to 0. Because that's the things we want to toss out. So literally, in order to find the bad numbers, that's the easy part. Okay? I just need to set the denominator equal to 0 and then solve. Okay, easy. Okay, next. Okay, um, getting a little cottonmouthy, guys. Been talking to you guys for probably the last 2 hours. Second thing we need to figure out, once we do that, we need to figure out when is this thing equal to 0. So what are the zeros? Now, here's the thing. Okay, because we're always working on functions, okay, functions, I want to know what makes this thing that's the left side, which is the function, which is the entire left-hand side, and we need, and I didn't say this before, but I need to reiterate this. This thing already started out with this thing being less than 0, but we need it to be 0. So if there was something else over there, I would subtract it over, okay, and we need it to be 0, and we'll blend it into everything, okay? So here we go. So this thing, I want to know when this thing is equal to 0. So what I'm going to do, I'm going to set this function equal to 0. Boom. Okay, solve. Well, you clear the fraction. That's easy. Okay, set each one of these equal to 0. Boom, boom, boom. And x equals -1, x equals -2. So now we have two things. We have, so these are I always call this Rush's 5-point hit system. I apparently I didn't buy into it too well. Okay, first things first, get it factored and ready to rock and roll. Make sure you box that in. That's very, very important, this guy. Okay, then you want to figure out what makes it bad. That's the denominator stuff. What numbers make it equal to 0? That's the numerator stuff effectively, because when you're always going to clear the fraction out. Cool, right? Now, if checkpoint 1 and checkpoint 2 and checkpoint 3 are good, then the next checkpoint is going to be awesome. Okay, so the next checkpoint, if I don't mess up all the things I'm doing here, the next checkpoint is going to be awesome, and this is why. Okay, so you already factor everything out. It's on one side. You got your bad numbers, you got your zeros. Now you're going to create what's called a sign chart. A sign chart is a cool way of figuring out when it's above and below the x-axis. Okay, I'm going to show you. Okay, so the numbers that go on here are your bad numbers. Okay, so the bad numbers, they're always going to be bad. Okay, so so a lot of people like to I like to put undefined there because that's what they really are. So that's what I'm going to put there, an undefined. And then my zeros, I'm going to put them in order. I'm going to put, this is a 0, and this is another 0. And what I mean by zeros, those are your actual zeros, right? The things that make those functions equal to 0. All right, so here we go. It's called a sign chart. Why? Because we can actually use the sign to actually get the number that it is. Okay, so check this out. Okay, look at a number that's over here. Okay, this is -5. Okay, so we plug that in. Okay, I'm going to plug it into this function that we had. That's the original, but we have it all factored out here. So instead of plugging it into here, we're going to plug it into here. And what I'm looking for is to see what numbers is it going to be here. Now, I'm just going to keep track of the signs, though. Okay, watch. So when I plug in -5, I get negative, right? Because -5 plus 1 is a negative number, times another negative, times another negative, and that gives me a negative effectively. Right? Makes sense. Okay, in between here is -3. Well, that gives me a negative, and then a negative, and then a positive. So now that turns this guy positive. Whoop-de-woo. And then when I do this, you notice that this guy is going to be negative. Same kind of deal. And same thing here is going to be positive. Okay? So now we do all of that. If we do all of that, what does this tell us? Well, this tells us the answer for all of our inequality issues. So we're finally, after we get here, so we get to right here, which is step 3 in this big system. Okay? This is the big way. If you can figure this one out, we're ready to rock and roll. Finally, here we go. All we have to do is take the answer we need. We're looking for when this guy is less than or equal to 0. So let's shade that in. If we're looking for where this thing, which is why we made his bad guys, his zeros, and put it on his sign chart and plugged it into him, we're looking at him, right? So we actually just need to give when this thing is less than, which is negative, or equal to 0. So less than would be here. These are all negative. You can never have anything that breaks your function. That's no good. So undefined will always be not included. Okay? Now, We can't have any positives, that's no good. But hold on, it could be equal to 0, that equal sign, right? So if that equal sign's there, I can definitely include my zeros. Okay, beautiful thing. Okay, now the negative is what I'm interested in though, because it wants to be less than. So anything that's negative, I'm going to include. So the answer to this guy's inequality is not just one simple x is less than something else, like how we normally have for the linear guy. It's everything we have shaded in green. So what is this going to be? That's negative infinity to negative 4 soft union negative 2 to negative 1 hard. And that's the answer. Because that's the answer you were looking for. Now, check this out. This is the best part of this. Okay? You just didn't solve one inequality. You solved every inequality. What if this thing, and we'll do this in red, was give me greater than 0. Only greater than 0, Resh. I'm like, okay, cool. Then that means, and I'll put that in blue now. Well, greater than 0 doesn't mean 0 anymore, and it only means positive stuff. So that means I'm looking for this stuff here. I don't want to undefined, can never have those, okay? I want no equal to 0, so I can't have any zeros, but I want greater than. So those are all the numbers, all the x values. So the sign chart gives you all the answers for any inequality they could ask you about this. So that's why the sign chart is so powerful. Not to mention, it's the only way you can do it. There's no other way to do it. So even if you don't believe me and you say there's got to be a shorter way, no, this is the only way, unfortunately. All right. So again, if you got it all over there, pull it all over, factor it out, make it greater than 0. Well, whatever the inequality is, right? Bad numbers and zeros, make sure you solve those out and make sure you figure out what those are, since the denominator equals 0 for the bad numbers or the undefined. The zeros, set your numerator equal to 0, go for it, right? And then finally, go through, draw your number line, put your things on there, test numbers inside of that function, the guy from that was in the yellow in the beginning, right? Okay, test numbers in there, and then figure out what they want. Do you want it greater than 0, less than 0? Okay, then you're home free. It's really, really that simple. Okay, I'm gonna come back. One more video after this. I know this is a lot, but this is not just it. Okay, it doesn't always alternate. Like, it's not always gonna be minus, plus, and there's more to practice than this. Okay, so we're gonna do a couple more, but so we're running about a little long. So next video we'll do a quick overview and we'll do maybe 1 or 2 more examples. All right, guys. Keep pushing. I know it's a tough time right now, but all of us are trying to do our best. So let's keep doing everything we can to communicate, stay together, and let us know if you guys need anything. Okay, we're here. All right, guys. So if you guys got any questions, by all means, send us an email. I'll see you guys later. Bye.